The electrons, which are negative, are attracted by the protons, which are positive, and vice versa. But here in the nucleus are other particles with no electrical charge, called neutrons. Very important characters, too, as we shall see. And equally important when it comes to atomic energy is what scientists call the atom's binding force. It's a kind of cosmic glue holding the nucleus together. Then, in 1939, some scientists were experimenting with transmutation of uranium. What would happen, they wondered, if they fired a neutron at a uranium nucleus, already the heaviest in nature? Why not try? So they tried. And the result? Nuclear fission. Instead of a minor change, the atom split in two. Truly a discovery to change the world. For what had happened when the uranium atom split was a kind of double miracle of science. Half of the miracle concerned that binding force we spoke of before, that kind of cosmic glue which holds the atom's nucleus together. We still don't know all about that binding force yet, but we do know it is equivalent to mass. Therefore, we may speak of it as having a kind of weight of its own. Now, the two atoms into which a uranium atom splits also have binding force. But for some reason, it takes less of that glue to hold them together, and in the process of fission, a tiny fraction is left over. What happens to it? It explodes as energy, proving Einstein's theory that mass and energy are really the same. But we spoke of a double miracle. To understand the second one, let's slow down that fission 1 million or so times. A single particle starts the reaction, splitting the uranium atom. Here now is the release of energy as heat and blast. Here are powerful rays being given off, similar to X-rays. But here are free neutrons driven out with tremendous speed. And provided there is sufficient U-235 present, what science calls a critical mass, those neutrons bombard other uranium atoms, causing them to split and split still others. The result? A chain reaction. Over 1 million billion atoms exploding within 2 seconds. And the force? It would take Yankee Stadium full of dynamite to equal the energy released in the complete fission of an amount of U-235 the size of a baseball.